I'm Beth Pariseau, Senior News Writer at Informa Tech Target, and this is IT Ops Query Season 3, Observability in the Age of AI. Ameet Talwalkar joined observability vendor Datadog in January to lead a new AI research lab at the company. He is also an associate professor at Carnegie Mellon University. Previously, he has also worked as a venture partner at Amplify Partners, co-founder and chief scientist at Determined AI, which created an open-source deep learning training platform that was acquired by Hewlett-Packard Enterprise in 2021. He has also worked as an assistant professor at UCLA and holds a PhD in computer science with a focus on machine learning from NYU. Thank you for being with us, Ameet.
Thanks for having me. I'm excited to be here.
Yeah, it's great to virtually meet you too. So first things first, what made you want to join Datadog, given you already had a career in academia? Why now?
Yeah, no, it's a great question. So I feel like it was a pretty unique and I think really high impact opportunity for me for various reasons, maybe three of them. One is the first kind of just the state of AI. And, as I'm sure you're aware of, it's kind of a pretty crazy time right now for our field. My take on it is that, it's also a very hype-filled time for our field, right? Like I think these frontier models, the GPT-4, the Claudes of the world, they're amazing. But I have this strong belief that in order for us to actually kind of move from hype to impact, we're going to want to move up the stack a little bit in terms of having some balance between relying on these general purpose models and on specialized approaches, whether it's specialized models, data, evaluation, really focus on specific problems. And then, second, Datadog, I think, is super well positioned for this AI impact up on the stack, right? It's focused on particular verticals, has access to data, wants to do evaluation based on real problems, serving real customers. It's also, a leading tech company that's able to move fast. It's, again, in this vertical where I think there are really, really natural AI problems. And before I joined, I guess I joined in February of this year, but I consulted with a company for maybe 6 months before that. I have a longstanding relationship with Alexi and Olivier, the two founders. And kind of one big thing I wanted to understand was kind of what their level of commitment really was in terms of AI. And when we first started talking, it was sort of casual. These are folks and friends that I've known for a long time and I really respect. But I was just increasingly impressed with their level of commitment in the context of AI, both in general, right? There's a bunch of different initiatives at Datadog with AI, but then also specifically in the context of what they actually meant in terms of research and their commitment to kind of doing open research in a lab.
Right.
So kind of my mindset in terms of what I wanted to be doing with AI and kind of how Datadog fit into that mindset just happened to be just an incredible fit. And I think timing wise, that was the third component. You asked, why now? Partly it was just a personal thing, right? I sold my company in 2021, stayed on for a little while to kind of help the transition. During that time, the world kind of, ChatGPT came out in 2022. End of 2022, the world kind of just drastically changed. And, I had been kind of planning for the last year and a half, trying to figure out how to get back into, I guess I have this long history of kind of straddling academia and industry, both before my PhD, during my PhD, and afterwards. And honestly, if you would ask me a year ago, I would have probably guessed that I would have started a company instead of doing this. But I just think the opportunity, like the data, the problems, the ability to have translational impact is sort of something that I'm seeing at Datadog that I didn't really see anywhere else. And just, it seemed like this great opportunity.
Right. And as of last week, one of the first projects that came out of the AI research lab was released open source, Toto, which I like the dog name.
Yeah.
A state-of-the-art time series foundation model trained on real-world observability data. So what will that allow IT pros to do with AI and observability tools that they couldn't do before day to day?
Yeah, maybe I'll take a step back and kind of explain why I'm so excited about it and then answer your question,
Sure.
which is, maybe it's related to kind of this third part of why I'm so excited about Datadog, right? The ability to work on real problems with real data at the scale that, you could do in industry is something that's harder to do in academia, right? And I'm not leaving CMU. I still have a group. I absolutely love my students. But there's this sort of type of research that you can do in an industry lab right now that you can't really do in academia. Mm-hmm. And so in terms of building Toto, we had a team of 15 or so folks working on all sorts of things together as this kind of big team, all kind of motivated by the same end goal. So that was just really fun, just interpersonally working with the team and kind of working towards this collective goal. I would say conceptually, again, I know I haven't answered your question yet. The other thing that I think is really exciting about this research, both Toto, but this general area of time series foundation modeling, which is the area that we're in, is that I think it's very analogous. Like where we are with time series is really analogous to where we were with language in 2018. 2018, right? These were the precursors to what has now changed the world with ChatGPT and so on. But in 2018, this model named BERT came out, and right there's this so-called BERT moment where all of a sudden this idea of basically training a large neural network on the entire internet, and then any new problem that you had involving text, you would, instead of kind of trying to gather data from scratch for that specific problem, you would start with this model that had already been quote unquote pre-trained on the entire internet. Details we can go into if you want. And it seems kind of like an odd idea that just training on the internet would help you with downstream text problems. But empirically, it just blew away everything else. And pretty quickly, it just became obvious that that's what everybody in NLP should be, in natural language processing, should be doing. And we've continued to move forward since then. But that's kind of where we, I think, are now with time series, with this idea that what we did with Toto, and again, there are other folks at other companies and universities kind of working on this as well, is exactly this idea of training a big neural network. And I guess what big means depends on your context. These models are still, they're significantly smaller than, say, whatever ChatGPT or the biggest language models are. But they're large models trained on a huge amount of time series data for a bunch of different problems. And then kind of to answer your question, the way that these can be useful, assuming that they work well enough, is this idea that you can use these models that are kind of trained once on a lot of data. You can use them to make forecasts or predictions, or eventually for things like anomaly detection, for any new problem that comes along.
Sure. So it's interesting because things like forecasting and anomaly detection are things that were already possible with machine learning. So
absolutely, yeah.
What's different with a small language model, I think would be the term, right?
I mean, these are I guess I wouldn't even call them, I would call it just these, neural networks. There's no, what we're doing with Toto and what other folks are doing as well, there is no language involved, at least right now. And that's something we should talk about later. But
sure,
these are just neural networks and the architecture for these neural network architectures are similar to the architectures used for language models. But what we're training on is time series data.
Yeah.
But your other question is exactly right. And I think this is, again, very much related to the LLM or the language analogy, which was in 2018, there was a lot of classical, what's called supervised learning, where if I want to solve a problem, I just gather a bunch of data, examples and labels for that. If I want to classify a piece of text as being a scientific text versus a blog post, whatever, I gather a bunch of blogs and I label them as blogs. I gather a bunch of scientific papers. I have an associated label with them that says they're a scientific paper. And then I can train a model from scratch just on that labeled data. What we found with BERT and these language models is that it turns out just empirically to be much, much better to first somehow have the model learn, and I'm being vague here just to avoid technical details.
Right.
But you basically wanted to ingest the internet.
Right.
And having it ingest the internet and learn something about the internet in some way helps for different downstream problems. And the story is exactly the same here with time series, which exactly as you said, I mean, it's the idea of autoregressive modeling for time series is not a new thing, right? And right. these are things that we use at Datadog. Everyone else uses them as well for various sorts of time series modeling, and they work well, right? But I guess there's maybe at least two ways in which these time series foundation models, which is what Toto is, and they're called foundation models because they're kind of like foundational. You start with them for any new problem. There's at least two ways in which I think they provide advantages over these more classical approaches. One is if empirically they just give better results, that's important. If I can do better forecasting, that's great. But the other thing is that they're potentially easier to use. So what we found at Datadog, right, we have a product called Watchdog that heavily relies, does anomaly detection, does forecasting. This stuff relies to a large extent on these more classical modeling approaches, and they get reasonable performance, but it requires work to actually get these models to actually, perform well. First, you have to train, you need historical data to train on. So if you're in a setting where now you don't have enough historical data, you can't train these models. Beyond that, there's some knobs to tune to figure out actually how to train properly to get these models to work. If alternatively, I can say, here's a general purpose foundation model, here's Toto, you don't need to train it at all for your particular task. You can just feed it in, some small amount of history and then it'll forecast what's next. Two, you don't need to tweak it at all. It's the same model for all your different problems. So basically at a high level, you get, potentially you have the ability to get your cake and eat it, right? You can get better accuracy and just out of the box use, easier to use.
Right. There isn't that kind of cold start issue, I think.
And then there's no cold start. Right. Exactly.
Right. Okay. And there was also a mention somewhere, either in the blog or on a LinkedIn post, about being able to remediate code in context with a model like this, or with some of the work that you're doing in the research lab. Can you say more about that topic?
Yeah. So, I'd say that in the context of this, I don't think Toto itself is directly, as described today, focused. It's kind of a little bit removed from code, but their clear next step, like where we are with Toto, is a nice starting point, but there's a lot of stuff we want to do there. And there's a lot of other work we want to be doing, maybe more agentic work that is directly aligned with what you just mentioned. So happy to talk about either all of those in whatever order you would like.
Yeah, I ask about the code remediation because I actually spoke with another guest this season about that and about the need to refine models more for that to be effective. So what is the work you're doing around that particular use case?
Yeah, so I'd say that like the goals of our lab, like one of the main goals of our lab are Toto and follow-ups to that, which we can talk about. But the other big goal is this idea of just developing specialized agents to help with automation, right? And so the idea is just that historically what we've done in observability is collected a huge amount of valuable data for our customers, but customers and users are now actively involved, whether it's in setting up monitors or, looking through dashboards to figure out root causes, or kind of to your point, debugging production code when we see failures. And so there's a natural question, especially, me coming from an AI ML background, we have this huge amount of data. Datadog as a whole has incredible domain knowledge in terms of the types of problems that humans are trying to solve using this data. There's a question of, can we put two and two together to kind of automate, at least to some extent, some of these tasks? And this kind of goes back to one of the reasons I was really excited to start working at Datadog. I think everybody is talking about agents now. This is the year of agents and AI agents. It's kind of an overloaded term, doesn't necessarily mean all that much, but it's really natural here that we kind of know users come to Datadog to do a lot of the same things, code remediation potentially being one of them, root cause detection, root cause of failures is another obvious one. And how can we kind of automate these things for them? And the other thing I'd say in the context of our research add-on, right, there are a lot of people working on agents, even for these sorts of problems, even within Datadog. And kind of going back to what I was saying earlier, this idea that we need to be moving up the stack in terms of not just relying on these frontier models, the GPT-4 and Claudes of the world. There are a bunch of ways to develop agents. And I would say the way people are largely developing agents right now is by saying, let me rely on these increasingly powerful frontier models and create scaffolding around them, right? So often people call multi-agent systems are potentially systems where instead of just using GPT-4 or Claude once, I'm using it 50 times, right? I have one instantiation of this model that says, make a plan for what this agent should do. And then you have different calls to the same model, or different, instantiations, but of the same frontier model to kind of try to execute on that plan or to refine the plan and iterate and so on. And to the extent that that works, great. But kind of a big hypothesis in the lab is that, maybe it's not black or white, it's all one or all the other. But at least for some of these steps, these general purpose models, which are just as good at writing Shakespeare poetry and potentially writing code and, answering questions about the internet, they're not necessarily going to be, they're great for demos, but they're going to have some gaps in certain domains. And we can potentially do a lot better, maybe not replace them altogether. Maybe we can, who knows? And it's hard for me to say a priori to what extent it's going to be specialized versus general. But at least for some components, we think leveraging the data that we have, our understanding of the problems that we have, is going to allow us to train specialized models, or maybe the whole agentic system end to end, in a way that's, potentially far more accurate and potentially also much cheaper. These models can be smaller and more specialized. So that's kind of a general approach that we're looking at.
Yeah. Those do seem to be the bugaboos with generative AI is cost and, ROI and hallucinations. People worry about the accuracy.
Right.
So what is next for Toto? What's the next frontier there?
Yeah. So, I mean, I think what we've done right now is pure time series, right? So the idea is that we're throwing a bunch of different time series. It's to some extent metrics from Datadog itself. This is kind of our own internal data, not customer data, as well as a mix of kind of general time series data that other folks in the research community are using. And again, I think this is already quite useful for things like forecasting and anomaly detection. But where we want to go next is kind of being more multimodal. What I mean by that, again, there's a natural analogy with language models. Language models at first were ingesting all of the internet, but now kind of these modern models are multimodal in the sense that they often have language and vision capabilities. And oftentimes these models are trained to some extent to get these capabilities by training on paired data, right? At least some of your data has paired, captions of an image. And these models tend to these they're called VLMs. And these VLMs tend to be much more powerful than training on multiple modalities kind of gives you additional sources of information, tends to lead to much improved performance. And similarly now with observability, right? Maybe our focus is not on vision so much, but the idea is we have a lot of time series data, a lot of telemetry data, but we have a lot of other data, a lot of text data in particular. And there's natural questions of how we can kind of have a model ingest as much data as we can, not just from time series, but from text or from whatever other modalities that we have, and use that combined model, whether it's to just improve forecasting even just of time series, or alternatively do different sorts of tasks. So kind of one really simple thing we're doing from a modeling perspective right now is trying to jointly model very simple type of text with time series. And that text is like literally just the queries of the metrics that we're generating and that we're using for training, with the kind of assumption that these queries have some meaningful metadata in them that might be informative of the behavior of the time series. And then you might imagine that you might want to do like QA on these time series. You might want to ask questions about, if I have a model that both understands text and time series, I could then, at query time or at test time, I can use the model to ask questions in plain English about what the time series is actually doing, which could be useful either to a human who's trying to debug things, or potentially, down the road, an AI agent who also is trying to, do some tasks.
Mm. Is there also potential for different types of visualizations than have been possible?
You mean in what context?
Dashboards, and in terms of automatically creating dashboards or surfacing information visually for human operators.
Yeah, I mean, I think absolutely that could make sense, right? The idea is that like a lot of the kind of root cause analysis is, finding a needle in a haystack. And the question then is, how do you help the user, whether it's fully automated or you're assisting the user, how do you make it easier for them to find what they want from this massive amount of data? And maybe the right way to do that is to provide visuals that make it more clear to what they're doing. To be honest, that's not the main direction we have been looking at yet, but I think it's a perfectly reasonable one. And I think maybe a general theme, I mean, I've listened to some of your other podcasts, I've heard some of your other guests, and anyone talking about AI, I think that the general theme is just that things are early and moving fast. So just because we're not doing it today doesn't mean that tomorrow it's not going to be the obvious thing to be doing.
Yeah.
So yeah, it's a perfectly reasonable idea, and one that also, given the power of AI models with vision, leveraging modalities where we know that things work is a really natural thing to be doing.
Sure. And speaking of things being early and moving fast, to get back to agentic AI.
Yeah.
How do you think that AI agents will change observability? And, what are the kind of frontiers of research you're doing in that area?
Yeah. So I think that everything I've kind of talked about so far has largely been in the context of improving observability for kind of classical software systems, right? You have systems that we already know, we're already using observability. We want to make observability better. We want to automate different kind of problems that users are facing with their existing systems. But kind of a really, very much related to your question, we're going to start seeing quote unquote AI native applications. We're already seeing them, and potentially new users, right? Instead of humans, AI agents, right? And I think both of those are going to provide new opportunities, but also challenges for observability and security, just generally as a field, but also obviously introduce kind of interesting research problems. So I think there's a bunch, right? And again, my default caveat here is that I'm sure that 6 months from now, when listening to this, it'll be comical that I've missed some really obvious things, because this stuff is just changing so fast. It's really exciting. But there are, I think, some that come to mind for me. One is sort of, I would say, human AI interaction. And so, right, this is maybe in the context of this is actually maybe more in the context of even classical observability, but this idea that if we're having AI agents, or if we're having AI sort of help users debug or find root cause analyses, they're going to have to interact with users in some way, right? And like the core things that we see right now are kind of some distinction between co-pilots and agents. A co-pilot is something that, you're interacting with it's a very interactive sort of interaction on the order of every second or every few seconds. An agent might go off and do more work and come back to you later and try to solve things. And ultimately what you're going to want it to do potentially is be proactive, not just bother you, but actually fix things, right? And that's great. But then there's kind of this analogy to self-driving cars where humans make mistakes. When we drive, we're not like part of the reason that people like self-driving cars is that there's a hope that, we're not great drivers collectively as a species. Maybe we can just avoid accidents and so on. But a self-driving car is also going to make mistakes and have some accidents. And the bar generally is higher on new technology that we don't understand. Similarly with observability, right? Like the user, right? The end user who is debugging something and trying to remediate it might make mistakes. They might delete a database, right? But when a human does something, you tend to understand it. If an agent that is more of a black box that we don't understand does something that we don't like, that's really problematic. And so, designing systems where we can trust what the AI is doing is going to be super important, because if things don't work and they don't work right off the bat, we're not going to trust in them. We're not going to use them. And so from a research point of view, I think, this is within observability, but more generally in AI, this intersection of AI meets HCI is really starting to blow up, because even if we're automating and AIs are involved more, humans still need to be involved in some way, and how they are involved, how they're interacting, how they guide the system, how they undo problems that happen, all these sorts of things are, we don't have answers to them yet. And partly it's because the AI itself is changing so quickly that what the interactions are going to be dependent on the kind of capabilities of the systems.
So in this case, HCI stands for what?
Sorry, human computer interaction.
Okay.
It's a field in, sorry. Yeah.
In my world, it's hyper-converged infrastructure. So I just wanted to clarify on that.
Yeah. All right, so that's one. I can tell you a few more
Sure,
if
go ahead.
that's
Yeah.
useful. Right.
Yeah,
So,
yeah.
I mean, I think it's related to this first one is going to be kind of domain-specific evaluation and benchmarking. And I think here the answer, here kind of, I think this is just generally true. And this goes back to this idea to AIs might hallucinate. They're great for demos, but that last mile can be hard. In order, I think, to move beyond that, we're really, really going to need benchmarks that are specific to the problems that we actually care about. Right. A lot of times what we've been seeing in the AI field is that we as researchers, often in isolation, are coming up with benchmarks. They might be challenging. It might be really cool that AI systems can actually do well on these benchmarks. But if they don't kind of correlate or translate to problems that we actually care about solving, then, kind of what are we doing? And I think related to this idea of human AI interaction or trust, a benefit we have, say, in observability over self-driving cars is that we don't need to automate all of observability overnight, right? Like, with a self-driving car, it's either self-driving or it's not. I think Olivier at one point had meant, he makes the analogy of you can have a self-driving car that only does left turns, right? Like that, it's not self-driving.
Yeah.
But we in observability can be a little bit more incremental, right? And we can optimize for precision over recall. And what I mean by that is we can optimize for, solving a subset of problems with really high accuracy. And even if that means we kind of, knowingly don't try to solve other problems that we're not yet good at solving as AIs. And that'll engender trust. And that'll be, I think that's the right strategy to take. But in and of itself, it's kind of hard to know what you're good at and what you're not good at. AIs are known to be overconfident. They're hallucinating. They're happy to give you an answer to everything. And so kind of carefully understanding when this stuff works and when it doesn't is going to be useful, even if you want to take this kind of more incremental approach.
Great.
And, and I will say in the research world, this is also like 10 years ago, it was kind of an act of selflessness to create a benchmark in the research community because it wasn't viewed as like pure research. But that's changed drastically. Like one of the premier research conferences for AI, it's called NeurIPS. They have this new benchmarking and data sets track, which is really blowing up. The community is really realizing how important this is. And I'd argue, shout out to our own work with Toto, we also released a benchmark on observability data. Again, from the point of view of saying that like time series forecasting is great, but it's pretty general and broad. And there was a question, the degree to which a model that's good for weather forecasting or finance is also good for, observability metrics that we care more about. And so we released a benchmark focused on the domain that we care about, kind of in hopes of kind of spurring community action towards kind of improving in that space.
And that's the thing, the acronym is BOOM, right?
Boom. Yeah. Yeah.
What does that stand for?
And honestly, like all good acronyms, I can't, what does it stand for? It does have it stands for something. And I know the B stands for benchmark.
Yeah.
And that's challenging because it's sort of like, I mean, I'm dating myself here, but like TCBY yogurt back in the day, it was like the country's best yogurt.
Yeah.
Right. So people called it TCBY yogurt. That was problematic.
Yeah.
Boom has that issue because the B stands for benchmark. The one of the O stands for observability. The M is for metric. But I'll be honest, I don't remember the full acronym.
I'm looking it up. It says
Yeah.
benchmark of observability metrics.
There we go.
Cool.
Maybe I'll highlight a third one that I think is
Sure.
also interesting here, which is just this idea that, and maybe this is going back to kind of what I was saying before, that fundamentally observability for AI native applications is going to be, I think, pretty different. They're not deterministic. They're more black box. From a security point of view, I think security is always an issue with applications, but there's kind of more of a surface area around how you can do prompt injection or code injection on LLM-based applications.
Mhm.
And so these are going to be challenges. I think in the context of, we at Datadog and I know others are creating tools, observability tools for AI native applications.
Yeah.
And in the context of observability, this is going to be a little bit of a change in the sense that unlike traditional software, when you write it, you roughly know what it's going to do. Maybe there'll be bugs, maybe there'll be issues, but you kind of have a sense of what's going on. These AI-based applications, you kind of just need to measure what these things are doing by looking at the inputs and the outputs, because the actual core of the system is this black box model. And so kind of from a security point of view, that means observability tools are going to be having access to what we're calling, primary data here, right? Like they're going to have access to whatever you feed into that model, which could be pretty sensitive user data, which from an observability point of view just means that, there are added kind of security requirements associated with doing observability on these sorts of tools. And I think also relatedly, these models are black boxes. I think fundamentally there's going to be things about them we don't understand, but there's this big area of research in the AI community called interpretability or explainability that has been trying to aim to kind of explain what models are doing. And I would argue that this community, and I've done a bunch of work in this community over the years as well, it's seen a bunch of kind of false starts. It's been a little bit of fit fraught in the sense that it's a really hard problem, and a way that a lot of people have tried to tackle explainability or, interpretability has been, let me in the abstract define what I think a good explanation might be. And then I'm done, right? But what we saw, people wrote a ton of papers and they had lots of visibility for these papers, but these were for, developing these new methods for explanations in isolation, which subsequently people said, okay, these are really popular, everyone's using them. To what extent are they actually useful for any downstream task? And it became clear that they're just not useful at all. These things are telling you something about a model and in the abstract, maybe that's cool, but if it's not actually helping you do anything, you could argue then why do I care about an explanation if it's providing no value? And so I'm saying this not to say bad things about a research subcommunity, but rather I actually think this is a real opportunity, right? In the same way that I am excited to be working at Datadog and working in the space of observability to move from hype to impact for AI in general, right? I want to be developing models and tools where I can measure impact by real benchmarks and real customer impact and so on. I think to some extent, the same thing might hold in the case of explainability for LLM observability, in the sense that, like, yes, we want explanations. We want to detect hallucinations. We want to understand sentiment. But whatever these explanations are, you're not doing them in the abstract. You're doing them because in the context of observability for AI native apps, this information needs to be useful. And if it's not, then you haven't solved anything. And so I think grounding explainable AI research in real problems could be a really good thing for the field, because I think it's just not really well defined otherwise. And I think there's a real opportunity research-wise there.
Yeah, because in the IT ops and DevOps world, abstraction and automation are great until they break.
Yeah.
And then it's another layer to try and interpret through.
Exactly.
Right.
And so I think we're going to need these tools, which is great, but it also means now the research community maybe can have a much more focused definition of how you define explainability or interpretability, which I think we've been lacking, and it's led to a lot of kind of underspecified work.
Right. One last question while I have you.
Yeah.
Another recurring theme that I've heard talking to people about AI on this podcast and off is, are robots coming to take our jobs?
Yeah.
So what effect do you think AI will have on human jobs, and how do you see that playing out long term?
Yes, I have also heard that a lot. On one hand, it's hard to make concrete predictions. Things are early, they're moving fast. And we'll tell you my personal opinion, which is that I think like previous waves of technology, this will be disruptive. It will change what we do, but I think it's more likely to change the way we work rather than replace us. And that doesn't mean it won't be disrupted. That won't mean we're not going to need to adapt. But my take is that it just means, in the same way that, the spreadsheet came out and we weren't all out of jobs, it just meant we did different things. In some sense, there were more jobs. They were just different types of jobs. To be a little bit more concrete about that, I'd say that there's sort of these like opposing forces at work. Again, I think there's a lot of hype and not enough impact yet, but I'd say that maybe two areas where there has been real impact of AI. I think it's fundamentally changed what we do already, or it's clear that it will, are search and like internet research, as well as coding. And so for these two examples, I think for both of them, the two different forces at work are, on one hand, it's a lot easier to generate a lot of things, right? It's easier to generate research reports, or it's easier to generate code, but there's also going to be new work for humans to actually make sense of or understand, or make sure that the code that you're generating actually works or does the right thing.
Yeah.
And we said, in the context of observability in particular, I think, or of coding, one way to think about it is, right, like it's very easy now to vibe an app into existence, but we don't really understand how well it works. We don't understand how safe it is. We don't understand a lot, how well it scales. And again, it's not like we haven't seen this before, in the sense that it's become easier and easier to code over the last 50 years, whether it was punch cards or higher level programming languages or moving to the cloud, whatever. It's constantly getting easier to code. Granted, it could be the case that with AI, we see orders of magnitude increases in productivity in terms of developing these apps. But so maybe we'll need fewer software developers, but now we're going to have a lot more apps, and they're going to be more opaque. We're not going to understand how they work. The outputs themselves might be non-deterministic, as we talked about, if these apps are themselves AI native. And there's going to be more of a burden to observe their behavior, ensure security. And so that's more work, right?
Yeah.
And so we might be doing different things, but I don't think, again, but who knows, right? Everyone is sort of prognosticating. No one knows for sure. But at least in the short and medium term, I'm pretty confident that our work will just be different.
Right.
Yeah.
Okay, great. Well, I really appreciate you taking the time. You're a guy with multiple careers now, and I appreciate you taking time out to share your insights.
Yeah, I thank you for having me. It's been fun chatting.
Likewise. This has been IT Ops Query Season 3, Observability in the Age of AI. If you have any feedback on this episode or want to share questions, comments, or stories we should consider covering, please reach out to me at beth.pariseau, that's PARISEAU, at informatechtarget.com. Please consider rating, reviewing, and subscribing to this podcast on your platform of choice, and tune in next week for our continued conversations with industry experts about how observability is shaping AI and how AI is shaping observability.